In this segment, we'll look at the object base class and two important methods of it. We'll also discuss the use of object references as universal references. Now, in the prior segment, we saw that margin vector inherited or derived from vector, as indicated by the extends vector declaration on margin vector's first line. It would appear that vector, lacking any extends declaration, does not derive from any other class and stands alone as a base class. But this is not true. If you don't specify an extends declaration, then Java supplies one for you, specifically deriving from the library class object. Technically, that's java.lang.object. So we should effectively read the first line of vector like this. You could even declare it that way directly if you like, but it's redundant to do so. The extends object is automatic. Now, object is the grandfather class, if you will, from which all other classes in a Java program ultimately derive, whether they're library classes like string or developer-defined ones like vector, and object is the only Java class that has no base class. Everybody else has at least object. And note that we now have margin vector deriving from vector, which in turn derives from object. It is perfectly possible and even common for a class to derive from another that in turn derives from yet another. The principle of inheriting all methods and members of your superclass applies also to your superclass, if you like. You inherit all methods and members all the way up to the ultimate superclass, object. As an example, go look up the Java docs for java.util.linkedList and find out how many classes are there between it and object. And does LinkedList have an isEmpty method? From what base class does it inherit that method? You want to look at the base class summaries that are under the main listing of methods. And returning from a pause there, I've got the Java docs up here as well. Here is the JavaUtil package, and then we drill down to the linked list class, and that's what we were seeing there. And the inheritance pattern, or layers, I guess you might say, is shown right here. This indicates in the Java docs that linked list derives from something apparently called abstract sequential list, which in turn derives from abstract list and from abstract collection in turn, and finally up here at object. You want to go down and look at the answer then is 3 classes, obviously, between linked list and object in the inheritance hierarchy, as it's sometimes called. Go down and look at the methods, and there is no isEmpty, except that when we look further down, we see that the Java docs always give you additional methods that you inherited from your superclasses. So apparently we get an iterator method from abstract sequential list, and then from abstract list, these methods, and then finally from abstract collection, or at least not finally, but third up from abstract collection, we get isEmpty. So there is in fact an isEmpty method of linked list, but it's inherited. Now, this kind of inheritance layer cake up here can be a little irritating when you're hunting for a method in the Java docs. Remember that just because the method isn't declared as part of the immediate class doesn't mean it's not there. It may be inherited from a higher subclass. You need to check the whole chain. And since everyone inherits from object, it's worthwhile to get familiar with its methods as they are a part of any class you declare or use from the library. You'd figure that only very universal methods would go in object, and that's so. It's a pretty short list. So let's bring up the Java docs for object, and you should do so too, please, while we're lecturing here. And those are in java.lang, the package where all the really central classes are for the language. And here is object. And there we go. So looking down at the methods, why don't we start with one that's reasonably familiar, which is toString. Okay? Now, we defined a toString for vector, but every class automatically inherits a toString from object because conversion to string is widely useful for debugging and printing. The object version of toString produces a rather debugging-like result, what the document describes as a string that textually represents the object. If you want something different or more readable, then you redefine toString like we did for vector. Now, question 2 here. Our vector.toString declaration should have been preceded by a small annotation to be really complete. What is that? And returning from a pause there and bringing up the ellipse here, we should have added @override, because we are in fact redefining the object toString rather than creating an original method of our own. So let's move on then to equals. Now we already defined an equals method for vector and discussed the reason for it. We want to do deep comparison instead of shallow comparison and so forth. The need for deep comparison is so universal that it makes sense for everyone to have an equals, and so equals is a method of object. Once again, our vector class has a method that looked original but is actually redefined from object. But question 3 here, is that exactly true? If I add, let's see here, an @override for my vector equals, what I get is a compile error. So why is that? Check closely the declaration of vector equals and of object.equals. Returning from a pause, where I hope you went and looked at the docs a little bit. Well, the object equals has a prototype equals object, like that. But our vector has a prototype equals vector. So they don't match. Well, that's sort of irritating. But then how could object equals be otherwise declared? It can't declare a specific parameter for one derived class. All the other derived classes would feel slighted. And only that one derived class would be able to use equal. So object.equals needs to specify a parameter that will work with any object. And the way to declare a reference that can point to any object is to use an object reference. We looked at the is-a relationship in the prior segment. Every object is a capital O object, since they all ultimately derive from object. So an object reference can point to any other type, or to be exact, any other class. The use of object references as universal references runs throughout the Java libraries and through many Java programs. However, this does not mean that objects of type object, the syntax gets a little awkward here, does not mean that such objects are common. Indeed, it's almost unheard of to actually write new object, since all you'd get is a rather boring object with default implementations of all the object methods. The object class is intended to be used as a base class for more sophisticated classes, and the members and methods of type object appear only as part of larger objects by inheritance.